All right, in this video we're going to look at some more advanced unit conversions. So make sure you've watched my previous video to be up to speed. All right, so in this first problem we are asked how many square feet are in 10 square yards. All right, so we want to convert square yards to square feet. Now we have these conversions here. We know how to convert yards to feet, but how do we convert square yards? Well, let's see. What we'll do is we'll start with our 10 square yards. All right. And what we want to do is we want to convert to feet. So what I want to cancel the yards. So I'm going to write this as a fraction with yards in the denominator. So I'm going to write 3 feet over 1 yard. All right. So I'm going to multiply this by 3 feet over 1 yard. Now, this won't do the trick because here I have square yards, here I have yards. So this isn't going to cancel the yards. But what I can do, there's two different ways to look at this. I can multiply by this fraction twice, and then I'll have yards twice, and that'll kill the yard squared. Or I could just square this expression. That's supposed to be a 2. All right? And so if I square this, what do I get? I get 10 square yards times, well, when you square a fraction, you square the numerator and denominator. So you get 9 square feet divided by 1 squared is 1 square yards. And now I have square yards. Now they do cancel off. And what do I get? I get 10 times 9, which is 90. And the only units left are, and I'm dividing by 1, and the only units left are square feet. And so there's our answer. 10 square yards is equivalent to 90 square feet. All right, here's another one. How many cubic centimeters are in 5 cubic inches? Well, let's look at our conversions. I can convert centimeters to inches here, right? So let's write down 5 cubic inches. I'm going to multiply this by something so that I get cubic centimeters. I've been talking too long today. My tongue is just tired, I think. So let's see. I want to cancel out the inches, so I want the inches in the denominator. So I'm going to multiply this by 2.54 divided by inches, centimeters divided by inches. 2.54 centimeters divided by 1 inch. Now, just as before, this isn't going to cancel the inches, right? Because I need cubic inches down here. So what I need to do is I need to cube all of this stuff. Okay, so let me rewrite that with that stuff cubed. When you cube 2.54, you get approximately 16.39. I did round here, so this is no longer equal, it's approximately equals. When you cube 1, you just get 1, and then I have cubic inches. Okay, well now I'm good to go. I can cancel the cubic inches, and 5 times 16.39 is 81.94. And again, I'm rounding to 2 decimal places. The units that are left over are cubic centimeters. So there's our answer. All right, in this problem we're asked, how fast is 20 meters per second in miles per hour? So we're measuring it first in meters per second. We want to convert it to miles per hour. Well, I'm going to write down 20 meters divided by 1 second. Okay, now I want to convert this so that we have miles in the numerator and hours in the denominator. Okay, so the first thing we need to do is convert meters into miles. Let's see how we do this. Well, here's our unit conversions. Okay, meters, meters, meters. Let's see, I can go meters to, it looks like maybe meters to centimeters, centimeters to inches, inches to feet, feet to miles, right? Now, you may have unit conversions to let you do this quicker, but based on what I have here, that's what we need to do. Okay, so meters to centimeters. All right, so I want the meters to cancel, so I'm going to put the meters in the denominator. Okay, that will cancel the meters. Now I want to cancel the centimeters. So I'm going to use this, put the centimeters in the denominator, 1 inch divided by 2.54 centimeters. That will cancel the centimeters. Now we need to convert from inches to feet. All right, so I want the inches to cancel, so I'll put those in the denominator. That cancels the inches. And we will go from feet to miles. I want the feet to cancel, so they will go in the denominator. And we have 1 mile in the numerator. That cancels the feet. Okay, so let's compute this out. We've got 20 times 100 times 1 times 1 times 1 divided by 1 times 1 times 2.54 times 12 times 5280. What do we get? Well, in the numerator, 20 times 100, that's just 2,000. And in the denominator, we get 16,0934.4. And what units are left? Well, these are miles per second. So I'll just write miles up here and second over here. Okay, well, we got miles per second. We need miles per hour. So now I got to convert these seconds into hours. All right, that's not on my unit conversion sheet, but I think we know how to do that, right? We know how many seconds there are in a minute, and we know how many minutes there are in an hour. So let's do that. All right, so I want seconds to cancel, so I know that I need that in the numerator. I know there are 60 seconds in 1 minute, and I know there are 60 minutes in 1 hour. Notice that seconds cancel here, minutes cancel here. So I've got 2,000 times 60 times 60. And that is 7,200,000. And what do we have left here? We have miles in the numerator. And we have hours in the denominator. So we have one final computation to do, and that is to compute this. And that comes to approximately 44.74. And this is measured in miles per hour. And you always want to make sure that you've got the units right, and also think about, is this reasonable? 20 meters per second, a meter is about 3 feet if you're used to English units. And so I'm thinking about something traveling at that speed. It seems reasonable that might be around 45 miles per hour. So that sounds reasonable. Now, if I got 4,000 miles per hour, I know something was wrong, right? Or if I got 0.4 miles per hour, yeah, that doesn't sound right. So always take a look at your final number and just ask yourself, does that sound reasonable? And in this case, I think it is. All right, in our last problem here, we're told that a substance weighs 2 pounds per cup. For every cup of the substance, it's gonna weigh 2 pounds. How many quarts of the substance would weigh 5 ounces? Okay, so we know that 2 pounds of the substance corresponds to 1 cup. So the way I would tackle this problem is by setting up what's called a proportion equation. All right, so I have this ratio here. And notice in the numerator I have a measurement of weight, and in the denominator I have a measurement of volume. All right. Now I want to get another ratio of weight to volume. I'm told that the weight is 5 ounces. So what I'm going to do is I'm going to put 5 ounces up here. And I want to know how many quarts. That's a measurement of volume. So that's an unknown. So I'm going to put x down here. So I want to know what goes here. What's the value of x? Okay. So to get at this, what we need to do is we need to get the left-hand side to be in terms of ounces, right? And what we want is the denominator to be in terms of quarts, because we want to determine x in terms of the quarts. So that's what we're going to do, is we're going to convert 2 pounds per cup into ounces per quart. So let's go ahead and do that. So I need to convert the pounds to ounces. How can we do that? Well, if we look at our chart, we see that 1 pound weighs 16 ounces. So I will multiply by 16 ounces over 1 pound. That will cancel the pounds. Good, I got my ounces. Now I need to convert cups to quarts. Okay, let's take a look. 1 quart is equal to 4 cups. Or I could use this one. 4 quarts is 16 cups. Doesn't matter. I'll use this one. 1 quart is the same as 4 cups. So I will multiply this also by 4 cups over 1 quart. And notice that that will cancel the cups. And so at the end, I'm going to have ounces per quart, which is what I want. But I have to multiply all this stuff out. Okay, so in the numerator, I have 2 times 16 times 4. That's 128. And what are the units? Ounces. In the denominator, I have 1 times 1 times 1, quart. Okay, great. So this is what I'm comparing to this. So this thing is equal to 5 ounces over x, right? So I'm solving for x. So I'm taking this equation here and solving for x. How can I do this? Well, one thing you can always do with a proportion equation is you can reciprocate both sides. So flip them both upside down. Well, that's useful. I would always do that if my variable is in the denominator. This will get it into the numerator. Now, what can you do with any equation? You can multiply both sides of the equation by any non-zero number you want. Well, the number I want to use is 5 ounces. So I'm going to multiply both sides by 5 ounces. Why do I want to do that? Well, because it kills them over here. And now I have x equals. What does x equal? Well, it equals what I get when I simplify what's on the left-hand side. Notice the ounces cancel. I have 5 times 1 divided by 128. This is 5 over 128. Notice that the units left over are just quarts. Right? So the x equals 5 over 128 quarts. If you want to see that as a decimal, just go ahead and compute that. And we see that x equals 5 divided by 128 is 0.039. So this is my final answer. 0.039 quarts of the substance would weigh 5 ounces.